So today we are going to talk about another approach to solving for x squared. So again, our goal in this chapter is to kind of see how many different ways we can solve for an x squared term, why eventually we need to use one method versus the other. So we've talked about factoring, which is a way to break down a problem and solve for x squared because you have a problem in parentheses that you can solve. And then we've talked about using square roots. So today, we're going to talk about something called completing the square, which will involve square roots, but we have to kind of transform our problem to get there. So in your packet, if you can turn to section 4.7. At the top of 4.7, there are 4 little warm-up problems, just to kind of get you into the thought process as to what we're going to be doing. 2 of them ask you to solve, and the other 2 ask you to factor. So how do you solve letter A for number 1? Jack, how would you solve that equation?
Square root and then
Yeah, so we need to take the square root of 49. And Jack, the square root of 49 is?
7.
Halfway there.
Plus or minus.
Plus or minus. So the square root of 49 is plus or minus 7. So 7 times 7 makes 7. Negative 7 times negative 7 also makes 7. So then we do need to add 5. But we're adding 5 to both 7 and negative 7. So Jack, your 2 answers for x would be
12 and negative 2.
12 and negative 2. Remember, you can always check your work. So if I plug a 12 in, 12 minus 5 is 7. 7 squared is 49. If I plug a negative 2 in, negative 2 minus 5 is negative 7. But negative 7 squared is 49. That's why I get 2 x answers there, because there's 2 different answers or solutions that would solve the equation for x. So make sure you have both. X is squared, I should have 2 answers. The next one, we have x plus 6 quantity squared equals 20. Ava, what do we do there to solve? So still taking the square root of both sides. What do you have to do with the square root of 20? Yeah, so 20 is 4 and 5, so that becomes 2. Excellent. So the square root of 20 is 2 square root of 5, and then the plus or minus in front of it. So Ava, this answer would look like there you go. So x equals negative 6 because you're taking the 6 over. Then the plus or minus sign and 2 square roots of 5. You can't combine those together. So this answer looks different because you have a number with the square root and I cannot combine a negative 6 and the radical value. Whereas the first one, because they're just numerical values that aren't radicals with them, we can just add those together. And then number 2 wants you to factor. We have x squared plus 18x plus 81. How did that factor, Chris? Right. This is a trinomial perfect square. So that 81 is a perfect square. It factors into the trinomial pattern where we have a plus b in parentheses and then it's squared. So trinomial perfect square. So then for letter B, we have x squared minus 22x plus 121. Dimitri, what's letter B become?
X minus 11 squared.
Right, x minus 11 squared. Why'd you put a minus sign in this one?
Because it's a negative 22.
Perfect. So it's a negative 22 inside. So I get that negative 22 by multiplying or foiling it out the negative 11. So both of those are trinomial perfect squares. The first one is a plus, the second one is a minus. The last question just says 27 plus some number is 6 squared. What would your number be? Jack?
9.
Why 9?
Because 36 plus 27 is 9.
Yeah, so 6 squared we know is 36. If you work the opposite and subtract the 27, that number would be 9. So 9 plus 27 is 6 squared. So today we are going to take these two problems at the top and try and kind of combine them together. So our goal will be to take an expression to try and make it a perfect square so that we can then solve using square roots. So we're still going to solve square roots, but we're also going to be working with how can we create perfect squares out of expressions. So that method is called completing the square. And we're going to see if we can try and do this for the first problem, and then we'll take it piece by piece. But if you look here, it says to solve x squared minus 8x plus 16 equals 25. Ignoring the 25, just looking at the left side of the equation. So remember, we're trying to take the first two warm-up problems and like condense them or squish them together to make it one problem. What could you do with the left side of the equation? So x squared minus 8x plus 16. Now, what can we do with that left side of the equation?
X minus 4 squared.
Right. So we can change or transform the left side into a perfect square. Because 16 is a perfect square, this is a perfect square trinomial. So we are factoring that left side. We're transforming it to make it look like a quantity squared, and then it's equal to 25. So now my problem looks like the first two warm-up problems, where I have something in parentheses squared. It wasn't originally like that, but we could factor it to become like that. Nick, what would you do next to solve it?
Take the square root of both sides.
Yeah. And the square root of 25 is?
5.
And?
Plus or minus.
Yeah, plus or minus 5. So you should have two answers just like we did for letter A. Nick, your two answers are?
9
So a 9 and a negative 1. So it takes the factoring concept that we were doing and applies it with the square root concept and enables us to solve. Now this only works for special problems. It doesn't work for every problem. So if I can't factor it as a perfect square, it's not going to work. Questions? So underneath, there is the term completing the square. Completing the square is a process of transforming ax squared plus bx plus c. And that's the form that we've used for factoring, ax squared plus bx plus c, to a perfect square trinomial. A perfect square trinomial is like the problem above, where I can then factor it to have one parenthesis square. So our goal is to complete the square, meaning we're going to do something with squares, so that we can break it down into a factored problem that is a perfect square. So we're going to try to take this step by step so you can kind of see how the process builds on itself. So in the words, to complete the square for the expression x squared plus bx, we are going to add b divided by 2 squared to the problem. I'm going to show you why, so that's the little algebra underneath. So my b is the middle number. If I take that middle number and cut it in half and square it, that means if something is squared, I would write it as x plus b divided by 2 times x plus b divided by 2. So remember, when I'm factoring, I should be able to FOIL to get back to my original problem. So if I did, I'd have x squared, and then I'd have b divided by 2 times x, and b divided by 2 times x. That gets me bx. Because if I'm adding those two things together, that goes down to just the value of b divided by 2. Because I now have two of them, and if I have two of them and I'm dividing it by half, I get that middle value of b. So because the parenthesis is the same, I have the same factors in each parenthesis, I can combine them together and make it a quantity squared. So that's going to be our goal. So if I take b and cut it in half, I then get this value that's a perfect square that we can use as factoring. Because anytime you square something, it's a perfect square. 3 squared is 9. So squaring 3 makes it 9, it makes it a perfect square. So our goal is going to become with trying to create this value that makes our quantity a perfect square. So at the top of the next page, it tries to get us to kind of think about how can we create that value. So we're going to try and make a number so that I have this quantity that becomes a perfect square. We're going to be picking the number by using a little process. So it's nice that there's a process to use. So to find the value of c that makes the expression a perfect square trinomial, that means that last number needs to be a perfect square. We have a couple of steps to kind of work through that. So we are going to take half of the coefficient of x. So I'm going to write this up here. So we have x squared plus bx and then plus c. So we're talking about this c value becoming a perfect square. So the first step is to take half of the coefficient of x. Well, the coefficient in front of x is b. So we're taking half of that. We're going to take the middle number and cut it in half. The reason I'm cutting it in half is because it goes in both my parentheses. And if I have half of something plus half of something, it makes a whole. Again, that's why we're cutting it in half. So find the result of step 1, or let's say square the result of step 1. Meaning, I'm going to take that b divided by 2 number and square it. Because our goal is to find a perfect square trinomial. So a number back here that's going to be a perfect square, like 9, like 16, like 25. And if I square something, then it becomes a perfect square. Step 3 would be to replace c with whatever number we get. So if I get a 25, I'm replacing c with a 25. And then the last thing we'll do is factor. Our goal is to get this to factor to be a perfect square. So that is our end goal. How can I factor it so that it's a quantity square? I know it seems a little confusing, but if we work through a couple examples, sometimes the words make it more confusing than the actual example. So looking at the first two problems underneath, we're going to see if we can find c. And then once we find c, we're going to see if that problem can then become factored. So right now I have x squared plus 12x plus some number. Our goal is to make that number c a perfect square. The way I can do that is by following these couple of steps. There's 4 steps, but they're really not 4 true steps. So the first one says take half of the coefficient of x. That's this number right here. That's b. So I'm going to take that number and cut it in half. So I need a 12 divided by 2 is 6. cutting it in half is because the way I can make 12 is by taking 6 plus 6. So if I double it, I go back to 12. If I cut it in half, I have 6 plus 6. The second step says to square the result of that value. So now I'm squaring it, and I get 36. That's C, because it's now a perfect square. So I'm going to replace it and make an expression, x squared plus 12x plus 36. So I've created a problem that is now a perfect square trinomial. The last step says to factor this trinomial. So how would you factor x squared plus 12x plus 36, Chris?
X plus 6 or
Because 6 times 6 is 36, but when I add 6 and 6 together, I also get 12. So now I've taken a problem and made it a perfect square. So if you look at letter B, we have x squared minus 24x plus c. So if I follow the same process, my goal is to find c. So to find it, I'm taking negative 24 because we're taking the b value. It's negative this time. That's okay. We're dividing that by 2. Full negative 24 divided by 2 is negative 12. When you square negative 12, Cole, it becomes positive 144. Anytime you square a number, it's always positive. So that value is C that I'm going to plug into my expression to make a perfect square trinomial. So this is the number we found to create a perfect square trinomial. So Brady, how would this factor?
x minus 12 squared.
Good. X minus 12 squared. So it's like we're making our own factoring problem. We're finding a problem that can be factored. So I believe underneath there are a couple of problems before we move on. So the first group wants you to solve by finding square roots. So I have to make the left side a perfect square. And then I think the couple underneath just want us to see if we can create our own C value. So Gavin, how would you solve letter A? Okay, before subtracting 36, what could I do to this side of the problem? So yes, I know your brain automatically says get it equal to 0, but instead of doing that, what could I do with the left side? Yeah, how would we factor it? So we're going to factor it and make it x plus 3 squared. Because we want to use square roots to solve this, and if we're using square roots, we have to have a perfect square. And then, Gavin, what would you do? And yeah. And the square root of 36 is? And it's also negative 6. So we're going to have 2 answers. And those 2 answers, Gavin, are?
3, 9, and
Nope, you were right first time.
3.
3 and negative 9. So again, when you have an equation that's set up in a special order, that special pattern, I can factor the one side because it's a perfect square. It only works this way if it's a perfect square. So letter B, x squared minus 24x plus 144 equals 100. Michael, what would we do here? Yeah, and this is the one we just did above that we created ourselves. And then taking the square root, Michael, you end up with? So your 2 answers, Michael. My stuff. So 22 and how about positive 2? Questions? So the 2 problems underneath here says find the C value that makes the expression a perfect square trinomial. Then write the expression as a square of a trinomial. So first we're finding that number that makes it a perfect square, and then essentially we're factoring it. So taking the middle number, dividing it by 2. So Veronica, 22 divided by 2 is? 11. And then square that number and you get? 1, 2. Yeah. So my value for C to become a perfect square is 121. So x squared plus 22x plus 121. And then Veronica, when we factor that as a perfect square, you get x plus 11. Okay, perfect. X plus 11 squared. Does anybody know where that 11 comes from? Chris?
Square root of 120.
Right, it's the square root of 121. Or it's this number here, that b divided by 2, because I'm squaring it to get 121. So I have to square root it to go back to the original value. And then letter B, we have x squared minus 9x plus c. Jack, what do you think there?
C equals 20.25.
Okay, so how'd you get that?
-9 divided by 2 is -4.5.
Okay, so if you're giving me a decimal, what do you think I'm going to say?
Oh,
No decimals. That's the cheater's way out. We don't use decimals. So I'm going to make you use your brain. Can you actually divide this and simplify it? No. So then the next step is to do what with it? Square it. So I'm going to place parentheses around it and square it. How do you square a fraction, Jack? Because a decimal means you're going back to that calculator, you're squaring a decimal. We don't need to use calculators. How do you square a fraction?
Negative, or 81 over 4.
Perfect. 81 over 4. Square the top, square the bottom. So don't make it into a decimal. Keep it into a fraction. Always fraction. Unless it says to get a decimal or we're doing a problem that is a real life problem we're trying to find time. So square the top, square the bottom. We get 84 over 4. That's my C value. Or 81 over 4, I'm sorry. It's okay that it's a fraction. Not everything in life is going to be whole numbers. Got it? Ah, thanks. And it's negative. I was grabbing the one from the other side. Thanks, Gavin. So now we need to factor this into a quantity that has a square on the outside. I know it's going to be a minus because there's a minus here. What number goes in the parentheses, Nina?
39 half,
Yeah. Why, Nina?
because we do the square root of 81.
And the square root of 81 is 9. The square root of 4 is 2. So it's kind of like you're undoing it. You're finding this perfect square, but then to factor it, you're taking the square root of it. Questions? So these little pieces are trying to build us up into the last type of problem that we're going to look at, which is the whole process of completing the square. Because now we're going to be solving something. So if you look at the equation that we're given, we have x squared minus 10x plus 13 equals 0. Is this problem factorable? Josh, why not?
It's 13%.
It's not a perfect square. 13 isn't a perfect square. I can't just break it down and say x plus this number makes 13 because it doesn't work that way. It's not a perfect square. So we are going to make it become a perfect square by following the little steps over on the side. And the first step is to get rid of that 13 because it isn't a perfect square. There's no way I can make it a perfect square, so we're just going to get rid of it. And it says to eliminate c by adding it to both sides. So we can't physically get rid of it, but we can at least take it to the other side of the equation. So our first step is to get this c to the other side of the equation. So we're going to eliminate it, which really means just take it to the other side. So we're going to subtract 13. I'm leaving a little space here because we have to come up with a number that is a perfect square since 13 isn't. So I left a little space there so I can fill a number in. So what we've done above was called completing the square. We're going to do that now just in one step. So part 2 says find b divided by 2, which is what we've been doing. This guy here is b. And we're squaring that because that's that perfect square value. So b is negative 10. We're going to divide that number by 2. and we have to square it, so I get a value that's a perfect square. So Michael, negative 10 divided by 2, and square it, and you get 25. It says to add this to both sides, because now we have an equation, and if I'm adding a number to the equation, we have to keep it equivalent. So we're adding 25 to the left, because that's my perfect square value, but now it's an equation, and I also have to add 25 to the right. That's what you do to one side, you have to do to the other. Part 3, factor the left side as a perfect square. So if I look at the left side of the equation, we're going to factor this as a perfect square. Again, just like we've done above, but now we're trying to kind of combine a couple of things together, a couple of the small pieces together. How would you factor x squared minus 10x plus 25? Peter? X minus 5 squared. But now it's an equation, Peter. And on the other side of the equation, we have negative 13 plus 25. What is negative 13 plus 25? 12. So if I look at this problem and go back to where we started with a problem very similar. X plus 6 squared equals 20. Except it was already squared for us. That's how the problem was given. And that's how we've been working with the problems yesterday and on Monday. Now we've taken a problem that looks like any regular problem and we've changed it to become in that form by the process called completing the square. So the last part is to solve. So now that I have something in parentheses and you're solving it, how would you solve that? Jack? Right, so we're still using that square root process. That's not going away. It's just we have to create the problem to get it to work for us. So this is x minus 5. Jack, what do we do with the square root of 12?
2 squared.
Yeah, so that becomes 2 square root of 3. I solved it, so we have to take the square root, get a plus or minus. And then Jack, your answer says?
X equals 25 plus or minus 2 squared.
You're so close. What are you adding to the other side?
Oh, I said 5.
There we go. So now I have an answer that looks like the answers that we looked at the last meeting. Questions?
That's what you did under number 2, like, find.
Yes, so that's the perfect square number.
Is it always gonna work? Like that?
Always gonna work, yes. Because you are creating it yourself by taking a number and squaring it. So it's the same thing that we did up here. It's this same number here. It's just now it's in equation form, so I have an equal sign. Other questions? Alright, so I think there are some problems that we can practice. Is this at the bottom of your page or at the top of the page? Top. So see if you can do number 3. X squared plus 6x minus 4. So you need to flip back. What do we have to do first? Yes, I know 4 is a perfect square, but it's a negative 4, and a negative 4 isn't a perfect square. And the middle number, there's no way I can get a 4 becoming a 6. So just because that 4 is a perfect square doesn't mean it's always going to work for us. Because it still has to match with the middle number. So leave yourself a little space. You need to eliminate that number to the other side. So you're taking that number to the other side. Peter, what do you do next after we take the number to the other side? Yeah, so we're going to use b, divide it by 2, and then what do you do with that number after you divide it by 2? So 6 divided by 2 squared. What does that become? Yeah, that gives us 9. So here's the part that you can't forget. Now it's an equation. So this number is a perfect square and it will always work because you're taking a value and squaring it. We need to add that same number to the other side. Don't forget that part, keeping it equivalent. What you do to one side, you have to make sure you're doing it to the other side. Peter, how does this trinomial factor? Excellent. X plus 3, because 3 times 3 is 9, but 3 plus 3 is 6. So it's still meeting both rules. It has to multiply to be 9, but when I double it, I add it together, I get 6. And then we have 13 on the other side. So taking the square root, that was our whole goal. I want to get a quantity that we can take the square root of. Michael, can you take the square root of 13 or break it down? So we just keep it as? Yeah, the square root of 13. It doesn't get changed, it doesn't get broken down. So our answer would be negative 3 plus or minus the square root of 13. Questions? So looking at number 4, we have x squared minus 12x plus 4. Yes, 4 is a perfect square. But is there any way 2 times 2 is going to get us to 12? No. 2 times 2 will never make 12. So I still have to use this process of completing the square because I have to get a perfect square that works with 12. It can't just be any old perfect square. It has to work with what we have. So that first step is to eliminate that c value. So take the 4 to the other side. Leave yourself a little space. So just because it's a perfect square doesn't mean it's a perfect square that works with the middle number. Ava, what are we going to do next to fill in the blank here? And then we'll square that. So negative 12 divided by 2. And negative 6. Excellent. So always the middle number, you're cutting it in half. And then we're squaring it, and we get 36. Again, don't forget on the other side, we have to add 36. So the left side, Ava, factors as?
X squared, or x minus 6 squared.
There we go. And negative 4 plus 36 is 32. And now I can just follow the process we've been using. We have a perfect square, so we can take the square root. How does 32 break down, Ava?
16 and 2.
Excellent. 16 and 2. So don't forget the plus or minus. Taking the 6 plus or minus 4 square root of 2. What do you think so far? So we're going to look at the final set of problems here. And then we'll stop after these two. What do you notice about these two problems? It has a number in front of the x squared. That number is like coefficient in front of x squared. What else do you notice about letter? Let's look at letter A. What else do you notice about letter A, Michael? We can take out a 3. What's that called? GCF. They're all divisible by something. So we can take that number out because they all have a 3 in common. Michael, what do you get when you take that out? I want to get rid of that number completely. So if I were solving for x, how would I get rid of that number completely so that it's no longer in the problem? Peter? Yeah, let's get rid of it by dividing both sides by 3. So because I'm solving and my goal is to get x by itself, and right now I have that in parentheses, I'm going to divide both sides by 3 to get rid of that number. So, Peter, 0 divided by 3 is still 0. So essentially, we can just take the whole problem and divide by 3 and get rid of it. As long as we're doing the same thing to both sides, there's a 0 on the other side. 0 divided by 3 is still 0. So now using this process of completing the square, I've divided by 3, and now it's the same process that we did for the 2 previous problems. If there happens to be a number where 0 is, you would just take that number and divide it by 3. So you're just taking a 3 out of all of the values. You're eliminating that value. To still try and get the x by itself. So Peter, in the little blank here, we do -4 divided by 2 squared, and that gives you and again, don't forget to add it on the other side. And then we factor it. So x squared minus 4x plus 4 is x minus 2, and that's equal to 13. So 2, don't forget the plus or minus, and then the square root of 13. So the last problem, 3x squared plus 36 plus 150. Are they all divisible by 3? Yes. So I'm just going to put a big division sign. And trying to save us a step here. Divide it all by 3. Each piece by 3. Josh, when you divide everything by 3, what do you get?
X squared plus 12x plus 13.
So see if you can finish this problem completing the square, taking the 50 to the other side. Your homework tonight, 3 to 21 odd are like the little steps of getting there. So just finding a C value to complete the square, or getting it to factor because it's already there for you. 22 to 27, those are the 6 problems where you're going to do the whole process like we just did here. Volunteer to do 23 and 27.
We only have to do 4 or 2.
2 a semester, yeah. So 2 a semester. Nobody wants to volunteer, 23, 27?
I'll do it.
Chris, you've got 2.
No one goes.
Fine, I'll do 27.
JT, you'll do
I don't know. I don't
23. Peter, was that Peter? Peter, 27?
Okay.
Thank you. And JT, 23.
I don't know.
You were being nice, Peter. Thanks.